Okay. Good morning, people. Let's start with the next chapter. The next chapter is the first chapter in inorganic chemistry. The name of the chapter that we have is called as periodic table. Very similar to what I think you people have done in 10th standard. 10th standard में किया periodic table. हाँ. So a part of the chapter is just what you did in 10th standard. अभी वहाँ से बस थोड़ा और आगे जाते हैं. Before we directly jump into the chapter, okay, we need to understand the journey to how the periodic table was actually formed. 10th standard तक हमने जो periodic table किया है, which periodic table we did in 10th standard? Modern periodic table. We also did Mendeleev's periodic table. Mendeleev के पहले Newlands Laws of Octaves और क्या क्या किया था people? Dobereiner's Triads और क्या क्या किया था? That's it. यहाँ तक किया था ना? ठीक है. So basic recap is of all these structures, periodic table जो initially how they started to structure the elements, to place the elements. We'll start with the history of the periodic table. Now the first scientist who tried to really arrange the elements was Lavoisier. And हम उसे बोल सकते हैं Lavoisier's periodic table. And he did a very basic classification, like not basic from today's point of view, but what he did is he arranged elements in two categories. First category क्या था people? He arranged the elements metals में, and second was non-metals. So the classification was based on metals and non-metals. How did he classify? Can someone give me some properties of metals? Metals will have basic properties, not even ionization energy and all. High melting point, some more properties. Good conductor of electricity, malleability and ductility, luster, reducing properties. Softer. Not all metals are soft, but ठीक है. So this was some broad classification कि metals and similarly non-metals उन्हीं का उल्टा हम कर सकते हैं. All the properties को थोड़ा सा change कर दो, उल्टा कर दो, non-metals. So basic first classification was metals and non-metals. However, eventually what were discovered that there are certain elements which show properties of both metals as well as non-metals. What are these called as? Metalloids. Eventually what happened when metalloids were discovered? अब क्या हो गया? They show properties similar to both metals as well as non-metals. हम बाद में periodic table पे do you know वो step या ladder बोलते हैं where you see metalloids. So eventually when metalloids got discovered, so we show that they show properties similar to both metals as well as non-metals, and hence we had to further improvise or upgrade the periodic table. यहाँ तक ठीक है? चलो. Now second, the second classification was given by Dobereiner. क्या बोलते हैं हम इसे? Dobereiner's triads. चलो, can someone tell me what is or what was Dobereiner's triads? He made groups of three elements in such a way that having similar chemical properties. Okay.
Show that the atomic mass of the middle element was approximately equal to the atomic mass of the other two elements.
Sure. Now what he did, he made groups of three elements showing similar properties. So the most simplest example लेते हैं सबसे पहले. For example, lithium, sodium and potassium. So he made groups of three elements showing similar properties. And now what was observed is lithium ka atomic mass is people 7. Potassium is 39. Now find the average of the two. तो कितना जाता है people? 7 plus 39 upon 2. How much is that? 46 by 2, that is 23, and that was the atomic mass of the middle element. As simple as that. Let's take one more example. Dobereiner's triads ka. Let's take chlorine, bromine and iodine. Chlorine is people 35.5, iodine is 127. चलो तो ऐड करते हैं. We have 127 and 35.5. So how much is that? 162.5. Divide that by 2. How much do we get? 81.25. Not exactly, but very close to the atomic mass of bromine. With me till here? So this is Dobereiner's triads. However, what's the drawback or limitation of Dobereiner's triads? Eventually, when more elements got discovered, ये rule possible नहीं था to follow. Actually, it was really well till calcium, but calcium के आगे, when elements were further discovered, and Dobereiner's triads, we had to eventually rule out, and we had to further improvise Dobereiner's triads. Did you people get that? Chalo. Before moving on to Newlands Laws of Octaves, we'll write about Lavoisier's periodic table and Dobereiner's triads. So on a new page, please write down periodic table. Write down development of periodic table. Development of periodic table. And write on the first one in that. Lavoisier's classification of elements. Lavoisier's classification of elements. Lavoisier's classification of elements. He classified elements into two categories: metals and non-metals. He classified elements into two categories: metals and non-metals. However, this classification cannot categorize. This classification cannot categorize metalloids. Cannot categorize metalloids. Next item. Dobereiner's triads. Dobereiner's triads. He made groups of 3 elements. He made groups of 3 elements. having similar chemical properties, having similar chemical properties called triads. Where the atomic weight of the middle element is nearly equal to the average atomic weight of the first and third element. The average atomic weight of the first and third element. The atomic weight of the middle element is nearly equal to the average atomic weight of the first and the third element. For example, quickly copy the examples on board. Okay, so these are the examples for Dobereiner triads. We move on to the next table. The next table was Newlands Law of Octaves. Please write down, people. Newlands Law of Octaves. And what was Newlands Law of Octaves? Properties of the eighth element. He arranged the elements in such a way that properties of the eighth element is similar to that of the first element. Like we have notes in music. C, A, B, C, musical notes. तो वैसे ही और हिंदी में हम जब बोलते हैं सारे गा मा पा, so first and if I go to the eighth element तो वहाँ पे कौन सा रहता people? Fluorine. And fluorine से eighth element क्या रहता people again? Chlorine. Or you can pick any one of these. उसका जो eighth element है will show similar properties. But then वहाँ पे again problem क्या हुआ? Because what were not discovered, noble gases were not discovered. Eventually later on we know that यहाँ पे कौन आने वाले हैं? Noble gases. So once noble gases were discovered, the law did not really hold true. And not only that, even before noble gas ka discovery, post calcium, the elements did not really match. The properties of the elements did not really match. He had actually also placed iron between oxygen and sulfur. ठीक है? चलो. So please write down Newlands octaves or Newlands law of octaves. He arranged elements in increasing order. He arranged elements in increasing order of their atomic mass and observed that properties of every eighth element was similar to the first. Properties of every eighth element was similar to the first. Like in case of music notations. In case of music notations. ठीक है. So musical notations, yeah, this is C D E F G A B C. These are musical notations जो हम सा रे ग म प ध नि सा ऐसे भी हम पढ़ते हैं. And the same musical notations यहाँ पे भी हम अप्लाई कर सकते हैं. First element similar to the eighth element. ठीक है. Copy this जल्दी जल्दी. Next, please write down limitations. Limitations. Rule is valid only up to calcium. Rule is valid only up to calcium. Rule is valid only up to calcium. Because after calcium, due to the filling of the d orbital, there is difference of 18 elements. Due to the filling of d orbital, there is difference of 18 elements instead of 8. There is difference of 18. Due to the filling of the d orbitals, there is a difference of 18 elements instead of 8. Next point. After the discovery of inert gas, this law had to be dropped out. The law had to be dropped out. He failed in case of heavier metals. As Fe was placed along with oxygen and sulfur. As Fe was placed along with oxygen and sulfur. Chalo. Before we go ahead with the next, we have to draw एक छोटा सा curve. Okay, next we have people is Lothar-Meyer curve. Now what Lothar-Meyer did is he plotted atomic mass versus atomic volume, and some common traits were obtained. Lothar-Meyer and Mendeleev were working simultaneously on the periodic table. Only thing is Mendeleev ने थोड़ा सा पहले publish कर दिया. He published his paper in 1968. Lothar-Meyer was doing exactly the same thing. Okay? He was trying to arrange periodic table because the properties of elements he thought were periodic functions of their atomic mass. Now if you look at Lothar-Meyer curve, what is observed is that all the peaks are occupied by alkali metals. So if I look at the peaks, they are all occupied by alkali metals. If you look at the descending portion of the curve, so descending portion of the curves may you have the alkaline earth metals. So you have beryllium, magnesium, calcium, strontium and barium. Metalloids usually occupied the lower part of the curve. Exact lower part nahi, but somewhere in the lower part of the curve. And last, the ascending portion of the curve was occupied by all halogens. So ascending portion of the curve may you see halogens. Now, the reason Lothar Meyer's curve was not, because he gave a curve, he did not really arrange them in a table. And why is Mendeleev credited with the periodic table? Is because his periodic table was better. He left gaps in between, as you all know, for undiscovered elements. Now, critics back then actually laughed on him, on Mendeleev, stating that invisible element. Yep, some really thought that probably he's कुछ भी guess कर रहा है, he's mad, that there are invisible elements, that elements which are not discovered. Now all that, or that structured form of the periodic table, was not given by Lothar Meyer. तो एक अलग controversy ये भी है, saying that Lothar Meyer का publisher थोड़ा slow था compared to Mendeleev. Mendeleev published the paper first. ठीक है, I don't really know उसमें से सच क्या है, but छोटा सा एक trivia है वो. ठीक है, so please write down Lothar Meyer's curve. We'll write the theory first, बाद में copy the plot. Lothar Meyer's curve. He plotted a curve between. Lothar Meyer's curve. He plotted a curve between atomic mass and atomic volume of different elements. Observations. First observation. Most electropositive elements. Observation number 1. Most electropositive elements, that is alkali metals, occupy peak portions of the curve. Occupy peak portions of the curve. Second point, less electropositive elements such as the alkaline earth metals, occupy descending portions of the curve. Next point, metalloids and transition metals, occupy the bottom part of the curve. Finally, the most electronegative elements, that is halogens, occupy the ascending portion of the curve. Occupy the ascending portion of the curve. Next point, on the basis of this curve, Lothar Meyer proposed that the physical properties of elements are periodic function. Physical properties of the elements are periodic functions of their atomic weight. Which then became the basis of Mendeleev's periodic table. Now, copy the curve. Then we start with. Chalo people. On a new page, please write down Mendeleev's periodic table. He arranged elements according to increasing order of their atomic mass. Arranged elements according to increasing order of their atomic mass. Seven periods and 8 groups in Mendeleev's periodic table. 7 periods and 8 groups. He left blank spaces in the periodic table. For the discovery of new elements. Such as first, gallium. What did he name gallium as? Eka-boron. EKA. Gallium. I'm sorry, it's Eka-aluminium. Gallium was Eka-aluminium. What does Eka stand for? It's a word. It's a Sanskrit word. EKA. So, gallium was aluminium. Scandium was Eka-boron. Aluminium. Scandium boron. Germanium silicon. पूरा नाम लिखने की जरूरत नहीं है कि शॉर्टकट ही लिखो. JEE is SI and technetium TC is Eka manganese TC. technetium is manganese. Technetium, people, is a man-made element. It is no longer present on Earth. तो वो gap complete ही नहीं हो रहा था. So, technetium is man-made. ऐसे बहुत सारे we'll learn in the periodic table that all the heavier elements eventually discovered, they are all man-made by colliding high-moving particles. Manganese, Mn. Next item, some demerits. एक demerit क्या है people? The position of hydrogen is still uncertain. Excellent. Position of hydrogen still uncertain. Position of hydrogen is still uncertain. It resembles both alkali metals and halogens in properties. It resembles both alkali metals and halogens. Next, isotopes. As atomic weight of isotopes differ, atomic weight of isotopes differ, they should be placed in different positions in Mendeleev's periodic table. They should be placed in different positions in Mendeleev's periodic table. However, there was no such place for isotopes. There was no such place for isotopes. Next point. Isotopes. Hydrogen का तो first point था, अरे वो हो गया. Next point. There were some pairs of elements. Which did not follow. There were some pairs of elements which did not follow the increasing order of atomic weights. The increasing order of atomic weight. There were some pairs of elements which did not follow the increasing order of atomic weight. For example, argon was placed before potassium. Argon was placed before potassium and cobalt before nickel. Even though they had higher atomic weights. Next point. There were some elements with similar properties but placed in different groups. There are some elements with similar properties but placed in different groups. Elements with similar properties but placed in different groups. For example, palladium PD and gold AU. Next point. Unlike elements were placed in same groups. Unlike elements were placed in same group. For example, what do you observe here, people? थोड़ा सा, you have lithium, sodium, potassium, पोटेशियम के बाद कौन आ रहा है? Copper. So can copper be placed? तो यहाँ पे if we consider this as group 1 belongs to alkali metals. कौन आ गया अचानक से? Copper. Then you have rubidium. Then अचानक से आ गया silver. Do they have similar properties? No. Same group but different properties. ठीक है? वो जो हमने example लिखे अभी palladium and gold. Palladium and gold, they are placed actually one below the other, but in the modern periodic table. But यहाँ पे देखो. So different elements showing similar properties, different groups, different properties, same group. ऐसा थोड़ा सा placement हो गया था. ठीक है? For example, again copy this. So copper, silver, and gold was placed in group 1 along with the other alkali metals. Along with the other alkali metals. ठीक है? So this was Mendeleev's periodic table. Now we move on to modern periodic table. Please add on a new page. Modern periodic table. Modern periodic table. It was proposed by Moseley, 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 and is based on atomic number. And is based on atomic number. He did an experiment in which he bombarded high speed electrons. He bombarded high speed electrons on different metal surfaces. On different metal surfaces, and obtained X-rays. he observed that now what he observed, people, is that the square root of the frequency of the X-ray is directly proportional to the atomic number. Okay? Or frequency is proportional to the atomic number. So he did it for different elements and he got a linear plot. Okay? Please copy this. He observed that square root of frequency directly proportional to Z. And hence he concluded that physical and chemical properties of elements are periodic functions of their atomic number. Chalo. Please copy the plot for me. Okay. Now let's continue with modern periodic table. So this formed the basis of modern periodic table. And then with the help of quantum mechanics, Niels Bohr theory, okay, Heisenberg, and Aufbau's principle electronic configuration, the modern periodic table was given. So we'll try to do half of the modern periodic table today. Let's see half ya jitna hota hai, and rest modern periodic table tomorrow. We'll start with the first group. First group pe we start with the first element, which is hydrogen. Now hydrogen does not belong to the first group, people. उसका पोजीशन अभी तक फिक्स्ड नहीं है. टाइम बिंग के लिए हम उसको कहाँ रखेंगे? ग्रुप 1 में. बट प्लीज रिमेंबर, हाइड्रोजन डज नॉट बिलोंग इन ग्रुप 1. हम फिर भी लिख के रख देते हैं हाइड्रोजन. सो विच आर द एल्कली मेटल्स? लिथियम, सोडियम, पोटेशियम, रुबीडियम, सीजियम एंड फ्रेंच. ठीक है, कुछ ना कुछ निमोनिक्स 10th स्टैंडर्ड में पढ़ा ही रहेगा इसके बारे में. व्हाट वाज द निमोनिक जो हमने 10th स्टैंडर्ड में पढ़ा था? लीना के आरबीसीज फरार. आई विल गिव यू कुछ निमोनिक्स इफ यू थिंक. क्या आपको थोड़ा बेटर पता है, आप मुझे बताओ. दो आई डोंट रिमेंबर निमोनिक्स फॉर ऑल, कुछ कुछ जो मुझे याद है आई विल शेयर इट विद यू. ठीक है, सो बाद में मुझे याद दिलाना व्हेन यू राइटिंग दिस. हम पॉज करेंगे तो if you want, I'll also give the exact mnemonic. So you have Lina K RBCs for R. This is group 1. Group 1 को हम क्या बोलते हैं, people? These are also called as alkali metals. Why are they called as alkali metals, anyone? We learned this in 10th standard. Why do we call this as alkali metals? We'll discuss this. ठीक है, याद दिलाना. चलो, now next. So this was group 1. Group 2, we have beryllium, magnesium, calcium, strontium, barium, and radium. The alkaline earth metals. We'll also discuss this. Why do you call it as? Why is there no earth here, but there is an earth in the group 2 elements? alkaline earth metals. इसका निमोनिक? ओके एक्सेलेंट. बीटा मांगे कार स्कूटर बाप राजी. ठीक है. So this is group 1 and this is group 2. Now group 1 group 2 के बाद we should actually do group 3. तो यहाँ पे ना ग्रुप 3 स्टार्ट होगा. थोड़ा अगर ऐसे बनाऊं मैं यहाँ से ग्रुप 3. सो ग्रुप 3 ग्रुप 4 ग्रुप 5 6 7 8 9 10 11 12 तक. आज लेट्स सी डी ब्लॉक में करेंगे कि नहीं करेंगे, बट आई स्टिल टेक यू टू ग्रुप 12. वी हैव जिंक, कैडमियम एंड मर्क्यूरी. सॉफ्ट मेटल्स. मर्क्यूरी तो एवरीवन नोज इज अ इन normal room temperature. So zinc, cadmium and mercury, these are called as soft metals. And you can also tell me the reason why they called as soft metals. Anyone who can give me the electronic configuration of zinc? Soft metals. Excellent. Zinc was 4s2 3d10. It has a completely filled electronic configuration. No need to form any bonds. जरूरत ही नहीं है bond formation की, and that is the reason that it is soft in nature. चलो हाँ, group 3 4 5 6 7 8 9 10. आज अगर कंप्लीट किए तो इसको इनको भी कंप्लीट कर देंगे. 11 एंड ग्रुप 12. विल कम टू दीज थोड़े टाइम में. नाउ वी गो ऑन टू ग्रुप 13. ठीक है. ग्रुप 13 में वी स्टार्ट विथ बोरॉन. ठीक है. सो द we call this as boron family. So the elements are boron, aluminium, gallium, indium, helium, nihonium. बैंगन, आलू, गाजर, इन, थैली, नहीं. ठीक है. That's the mnemonic for group 13. क्या करें? बैंगन पसंद नहीं, आप दूसरी भाजी ले लो. ठीक है. ग्रुप 13 को हम क्या बोलेंगे पीपल? विल कॉल ग्रुप 13 एज द बोरॉन फैमिली. Now usually जो the lower part of the periodic table that we are going to study, उनकी properties are mostly unknown. They're not really found. यहाँ के जो elements हमको मिलेंगे, all of them are radioactive, and their half-life is very very small. They've actually been prepared in lab by collision between protons and neutrons and electrons. वो सब collision से, and they're produced for a very small period, probably microseconds. Okay, so even आगे 2 साल में हम कुछ नहीं पढ़ने वाले, probably just उनका electronic configuration पढ़ेंगे. चलो, ग्रुप 13 के बाद वी मूव ऑन टू ग्रुप 14 एलिमेंट्स. बोरॉन के बाद कौन आता है? कार्बन. कोई तो ऑक्सीजन नहीं. ओके, कार्बन. देन द कार्बन फैमिली इज कार्बन, सिलिकॉन, जर्मेनियम, टिन एंड लेड, फ्लेवोरियम. ठीक है. निमोनिक इसका इज, ठीक है, केमिस्ट्री सर गेट्स सन की प्रॉब्लम्स फॉरएवर. ठीक है. ये इसका निमोनिक है. ओके, आई रिपीट, केमिस्ट्री सर गेट्स सन की प्रॉब्लम्स फॉरएवर. तो 14 को क्या बोलेंगे पीपल? विल कॉल 14 एज कौन सी फैमिली? कार्बन फैमिली। ठीक है, चलो लेट्स मूव ऑन टू द नेक्स्ट। ग्रुप 13 के बाद ग्रुप 14, ग्रुप 14 के बाद वी मूव ऑन टू ग्रुप 15। पे अटेंशन प्लीज। एनीवन ग्रुप 15 का फर्स्ट एलिमेंट अगर बताए मुझे तो नाइट्रोजन, नाइट्रोजन, फॉस्फोरस, आर्सेनिक, एंटीमनी, बिस्मथ। यस, थोड़ा कंट्रोवर्शियल निमोनिक है इसका, ठीक है। होपफुली ज्यादा लोग कोई वीडियो ना देखे। नेपाल, पाकिस्तान, आसपास सब भिखारी। MC इज मॉस्को। जो आप सोच रहे हैं MC इज नॉट दैट, ठीक है। दिस इज मॉस्कोवियम। सो एक और कुछ निमोनिक था बट ये वाला थोड़ा ज्यादा याद रह जाता है बच्चों को, स्पेशली फॉर। वापस एक बार, अरे वीडियो तो रिकॉर्डेड है ना रे, वो तो तू सुन सकता है, ठीक है। एनीवेज, तो कंट्रोवर्शियल निमोनिक हम फिर से नहीं बोलेंगे, ठीक है। चलो नेक्स्ट, इसके बाद मूव ऑन टू ग्रुप 16। ग्रुप 16 इज ऑक्सीजन फैमिली। अच्छा, ग्रुप 15 को क्या बोलेंगे फिर हम? नाइट्रोजन फैमिली, ऑक्सीजन फैमिली। फर्स्ट एलिमेंट ऑक्सीजन, देन वी हैव सल्फर, सेलेनियम, टेलूरियम, पोलोनियम एंड लिवर्मोरियम, ठीक है। अब इसके अलग अलग निमोनिक्स हैं। एक सिंपलेस्ट इज ओह शिट, सेटेपो, ठीक है। सो दिस इज व्हाट हाउ आई यूज्ड टू रिमेंबर, इसलिए मैं वही बता, ओह शिट सेटेपो लव। मेक्स नो सेंस। इफ यू थिंक कुछ बेटर है आप लोग भी मुझे बताना, प्रोबब्ली आई आल्सो लर्न समथिंग बेटर। और भी एक दो इसका था बट आई डोंट रिमेंबर, आई रिमेंबर इट लाइक दिस, ओह शिट सेटेपो लव, ठीक है। नाउ लेट्स मूव ऑन टू द नेक्स्ट वन, ग्रुप 17। ग्रुप 17 को क्या बोलते हैं पीपल? हैलोजेंस। ग्रुप 17 को हैलोजेंस बोलते हैं, तो ग्रुप 16 को बोलते हैं चैल्कोजेंस। ग्रुप 16 को ऑक्सीजन फैमिली के साथ साथ वी आल्सो कॉल देम एज चैल्कोजेंस। चैल्कोजेंस मतलब सॉल्ट बेस्ड। ग्रुप 15 नाइट्रोजन फैमिली के साथ साथ हम इन्हें बोलते हैं निकोजेंस या पिनिकोजेंस, ठीक है। पी से स्टार्ट होता है वो, निकोजेंस। चलो ग्रुप 17 एलिमेंट्स प्लीज। फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, एस्टेटीन, टेनेसीन। फर्स्ट क्लास बिरयानी आई एट टेस्टी, ठीक है। अलग अलग था इसका, फर्स्ट क्लास बिरयानी आइटम 8 टेस्टी, समथिंग समथिंग लाइक दैट, ठीक है। दिस इज ग्रुप 17। ऑल द एलिमेंट्स यहाँ पे, आई रिपीट, ऑल आर रेडियो एक्टिव, ये आपको सब याद रखना है। एंड लास्ट ग्रुप आप दे सकते हैं मुझे, दीज आर कॉल्ड एज नोबल गैसेस। सो नोबल गैस पीपल यहाँ पे याद रखना, स्टार्ट फ्रॉम हियर। तो ये कौन है? हीलियम, नियॉन, आर्गन, क्रिप्टॉन, जेनॉन, रेडॉन, ऑर्गेनिज्म, ठीक है। इसका निमोनिक है हीना, नीना और करीना। एक्सी का था कुछ, जेरोक्स लेने गए एंड समथिंग समथिंग। जिंदा रहना. Okay, you can make something Rn and OG को लेकर, ठीक है. But since we say noble gases so many times बार बार तो वो अपने आप रिटर्न तक तो मेमोराइज हो जाता है, ठीक है. So these are noble gases. Now, group 1 and group 2 elements except for hydrogen, group 1 and group 2 elements except for hydrogen are also called as S block elements. I repeat, उसमें हाइड्रोजन नहीं आता है people, क्या बोलते हैं हम इन्हें? S block elements. Now why do we call them as S block elements? ठीक है. Though we can start with hydrogen, I repeat, it's not an S block element. Can someone give me the electronic configuration of hydrogen? 1s1. Can someone give me the electronic configuration for lithium? 1s2. 2s1. So if I write the electronic configuration of the last shell, तो lithium में क्या आ गया वो? 2s1. If I go to sodium, 3s1. Potassium, 4s1. Rubidium, cesium and francium. यहाँ पे if you carefully observe, the quantum number is also giving the period to which your element belongs to. And the last electronic configuration is the same, and that last electron enters which subshell? S. That's why they're called as S block elements. समझा मैंने S block क्यों बोलते हैं? Similar lines में, can anyone give me the general electronic configuration for group 2 elements?
NS2.
Beryllium will become 2s2. Magnesium, people?
3s2.
Calcium, 4s2.
5s2.
Strontium, 5s2.
6s2.
6s2. 7s2. इन दोनों का general configuration or the general configuration for S block elements can be written as NS1 or 2. NS1 to 2, where N is your periodic, the principal quantum number or the period to which your element belongs to. S is the block, and या तो उसमें एक इलेक्ट्रॉन है या उसमें दो इलेक्ट्रॉन है. Easy. Now can someone give me the electronic configuration for the boron family? या boron से start करते हैं. What's the last shell configuration for boron? बोरोन का कॉन्फ़िगरेशन भी बता सकता है? पूरा कॉन्फ़िगरेशन लिखते चलो. 1s2, 2s2, 2p1 या 2s2, 2p1. ठीक है. I'll write it here. Can someone give me for carbon? 2s2, 2p2. Nitrogen would be 2s2, 2p3. Oxygen will become 2s2, 2p4. Fluorine 2s2, 2p5, and neon is 2s2, 2p6. Can I generalize it? Because अगर अभी मैं नीचे जाऊँ, so what will aluminium become? 3s2, 3p1. Silicon will become 3s2, 3p2. Phosphorus, so on and so forth. Can I generalize the electronic configuration as NS2, NP 1 to 6? For group 13 will be NP1, group 14 will be 2, 3, 4, 5 and 6. Yes or no? थोड़ा और बेटर करते हैं लेकिन. If I go to gallium, can someone give me the configuration for gallium? क्या होगा? Gallium will be 4s2 4p1. But you see बीच में gap छोड़ा है. Which subshell is filled after 4s?
3D.
Excellent, 3D. How many electrons in 3D? 10. The configuration is for gallium 4s2. ये 3D भर जाता है पूरा. You start from scandium 3d1, 3d2, 3d3, 4, 5, 6, 7, 8, 9, 10, 11, 12. तो यहाँ तक आते आते ग्रुप 12 तक आते आते स्कैंडियम सॉरी द 3D शेल इज कंप्लीटली फिल्ड. सो गैलियम के कॉन्फ़िगरेशन में बीच में गैप में कौन आएगा? 3D 10. विथ मी? दिस इज रियली इंपॉर्टेंट बिकॉज बाद में ये जो D में इलेक्ट्रॉन आया दैट प्लेज अ बिग रोल एंड शोज सम चेंज इन प्रॉपर्टीज जब हम इन पीरियड 4 के एलिमेंट्स की बात करते हैं. चलो. Similarly, can someone give me the electronic configuration for indium? 5s2 we could have written this as 5s2 5p1, but बीच में कौन आता है? 4d10. ये configuration है for indium. Yes or no? Indium के नीचे जाओ. You have thallium. What's the configuration for thallium? 6s2 6p1. You know what fills after 6s सबसे पहले? 4f14. Then कौन fill होता है? 5d10. So as you move from the 4th period between S and P, कौन सा सबशेल फिल हो रहा है? D. 5th पीरियड में आ गए तो D. 6th पीरियड में आने लगता है तो कौन फिल होने लगता है? F and D. And this is true for all the other elements. Did you will get that? Hence, the electronic configuration can also be written something as like this: NS2 NP 1 to 6. But S के बाद कौन फिल हो रहा है? D. And carefully observe, if S is 4, what is the principal quantum number for the D subshell? 3. Can I say it is 1 less than the principal quantum number of the S subshell? So if this is N, तो D का क्या आएगा? N minus 1 D. And how many electrons are there in that D? 10. If I move on to F, what is the relation between N of the S subshell and N of the F subshell? N minus 2. So the general electronic configuration for the p block elements can also be written as NS2 N minus 1 D10 N minus 2 F14 and NP 1 to 6. Did you will get that? Now there is one exception in P block. The element is placed in P block but does not belong probably to P block. कौन सा element है वो? Helium. Give me the electronic configuration of helium. 1 S2. That electronic configuration is similar to alkaline earth metals NS2, but of course it does not show properties. But where is it actually placed? Because it shows properties similar to noble gases. So एक exception in P block is helium. Though we have placed helium in P block, उसके electronic configuration में P आता ही नहीं है. With me till here? बोलो रे. चलो, so these were P block elements. Now P block से we move on to D block elements, and I think D block elements, the 3D series, ये elements आपको already पता है. Can someone quickly give me all the elements? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Science teacher, निमोनिक दिया नहीं था क्या? अच्छा, साइंस टीचर वेरी क्रूअल मैन. ठीक है, फेकोनी कॉपर जिंक, बीच में सिंधी भी डाल दिया. ठीक है, साइंस टीचर वेरी क्रूअल मैन, फेकोनी कॉपर एंड जिंक. Okay, now the configuration of scandium. Can someone give me the last shell configuration for scandium? 4s2, 3d1, titanium, vanadium, chromium, pardon me, 3d5. Remember 4s1, 3d5 exception tha. Manganese is also 3d5. Iron 3d8, 3d9 and 3d10, and copper भी exception में हमने क्या कर दिया था? 3d10. Now D block elements, because the last electron is entering in the D subshell. Can someone give me the general electronic configuration? So everywhere it is 4s, 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 4s2, 4s2, 4s2. But chromium में क्या हो जाता है वो? 4s1. 4s2, 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 4s2. Again copper में क्या हो जाता है वो? So what will be the general electronic configuration? NS. So the S subshell will either have how many electrons? Or so 1 to 2. बराबर. आगे, how many electrons are there in D? D starts from 1, 2, 3, 4, 5, 6, 7, 9, 10. And if N is 4, D subshell is 3. तो क्या लिखेंगे हम यहाँ पे? N minus 1 D 1 to 10. With me? Period 4 के जो transition elements हैं, इनको हम बोलते हैं 3D series. When you'll move below, उनको हम बोलेंगे 4D series. उसके नीचे जाएंगे 5D series, and बीच में ही lanthanides and actinoids आएंगे. With me till here? चलो, D block elements के थोड़े और कंप्लीट कर लेते हैं. स्कैंडियम के नीचे yes we have yttrium, and yttrium के नीचे we have lanthanum. Chromium के नीचे we have molybdenum, and we have tungsten. Now थिंक अबाउट डी ब्लॉक एलिमेंट्स इज, वो तो ग्रुप में सिमिलर प्रॉपर्टीज दिखाते ही हैं, इन सर्टेन केसेस पीरियड में भी सिमिलर प्रॉपर्टीज दिखाएंगे. आई रिपीट, दे शो सिमिलर प्रॉपर्टीज इन ग्रुप्स एंड इन सर्टेन, इसलिए पर्पसली ये लिख रहा हूं टू शो सर्टेन कॉमन ट्रेट्स. ग्रुप में भी सिमिलर प्रॉपर्टीज है एंड पीरियड में भी सिमिलर प्रॉपर्टीज है. I'll explain third time में. Similarly, chromium, molybdenum, tungsten, very high melting point. I don't know, tungsten filaments बल्ब बनाने की यूज करता है. तीनों के melting points are very very high. Next, उसके नीचे वाला है, बट वो रेडियोएक्टिव लास्ट में कर रहे हैं क्योंकि अभी जगह नहीं है तो बहुत क्राउडेड होने लग जाता है. देन चलिए ग्रुप 11 लिख लेते हैं. कॉपर, then you have silver and gold. remember, ठीक है, दोनों को ध्यान से याद रखना. always gift group 11 elements बर्थडे पे. तांबा मत, कॉपर मत दे देना, the elements below that. या ग्रुप 10 के एलिमेंट्स भी दे सकते हैं, which is nickel, palladium and platinum. Coin age metals, inert electrodes or electrodes used for hydrogenation or reduction reactions. Now when we say they show similar properties, iron, cobalt and nickel have almost the same atomic size, and because of almost same atomic size उनके बहुत सारे properties are also similar. Did you will get that? आज के लेक्चर में तो नहीं हो पाएगा, बट लैंथेनम के बाद यहां से स्टार्ट होगा आपका लैंथेनाइड्स एंड इनके भी निमोनिक है, एंड इवेंचुअली विल मेमोराइज लैंथेनाइड्स एंड एक्टिनाइड्स, जिनको हम आगे जाके बोलेंगे F block elements. With me till here? समझा? ठीक है? So, जल्दी दिस कॉपी करो. Stop here for the day. Next class, that is tomorrow, will complete the remaining part of the periodic table. ठीक है? चलो.